In the previous class, we spoke about different types of glucose transporters, and we basically classified the glucose transporter as insulin dependent and insulin independent glucose transporter. Of that, let us first talk about insulin independent glucose transporter. The mechanism of action of both insulin dependent and insulin independent varies. So let us take now the example of GLUT2 here. You already know that GLUT2, you have seen already it in the topic of absorption, right, from the cells into the blood vessel. Now, the GLUT transporter, as you can see over here, it is present in two configurations or two conformations. One as T1 and another one is T2. T1 is the one when there is glucose present outside. Okay, or in this case it could be, if we are talking about GLUT2 in the intestine, then it is the intestinal intestinal mucosal cells. Within that you have D-glucose, which will go now and attach to the T1. Once the T1 is bond with glucose, this will lower the activation energy, and this undergoes a conformational change. The transporter undergoes a conformational change to its another structure, that is T2. So this is T1 structure and this is T2 structure. This is one conformation that it can exist stably in. This is second conformation. So binding of glucose will change the structure to T2. Once it is T2, the glucose which was held here is released into that environment. And once there is no glucose present over here, it returns back to T1 configuration or conformation. Okay. So if we're talking it now, let us talk it with respect to in sorry, let's talk it in respect to blood vessels and GLUT2 present over on the liver cells or in the pancreatic cells. So from the circulation, the glucose enters into the T1. This brings about conformational change to T2, opens the gate so that glucose enters into the cell. Once the glucose is detached from that, it returns back to its T1 state. So what is the next mechanism? The next mechanism is obviously insulin dependent, and only one glucose transporter we know which is insulin dependent, that is GLUT4. So how does this happen? Let us assume a basal thing first. Okay. So in the basal thing, you can see here that the glucose is present on the outside. It has to now enter into the cells, correct? But only there are so many glucose molecules here, but only one GLUT4 is present. So what will happen? Once the insulin is released, it comes and binds with the extracellular insulin receptor present on the cell. And there is a cascade of secondary signals or intracellular signaling that happens, which will cause upregulation, or it will upstream the glucose GLUT4 receptors from the cytosol to the membrane. So now you can see the amount of glucose T4 transporters has increased. Again, by the same mechanism that we described earlier, it will exist in T1 and in T2 configurations, and it will be taken inside. So the major difference when we say insulin dependent and insulin independent is that here, for the GLUT4 to be expressed on the surface, you have to have insulin binding the insulin receptor and surfacing this GLUT4. So that brings us to the end of